Have you ever walked into a massive building, like a hospital or university, and just wondered how every single device gets a rock-solid internet connection? I mean everything, from critical medical equipment to thousands of student laptops. Well, it's not magic, it's actually a hidden physical network that's working behind the scenes. So today we're going to pull back the curtain on this unseen world.
First up, we'll map out how a building's network is structured. Then, we'll dive deep into its core, the mainframe, and see how the connection travels out to the intermediate frames on each floor. After that, we'll put them side by side to really highlight the differences. And finally, we'll look at the actual physical hardware that makes all of this work.
All right, let's kick things off by thinking about the big picture.
I mean, seriously think about it. You've got patient monitoring systems that cannot fail, doctors' workstations, guest Wi-Fi. The demand is just massive and relentless. The answer isn't just buying a bigger router. A single router would be a catastrophic single point of failure. You just can't have that in a hospital. No, the solution is a complex, structured system that actually acts a lot like a living organism.
And this is really the best way to picture it. Just imagine a central brain where all the information from the outside world comes in. Then there's a spine that carries that information all the way up through the building. And on each floor, you have nerve clusters that branch out to every single device. This whole setup is designed so that a small problem in one area doesn't crash the entire network.
So, let's start our journey at that brain, the absolute command center for the building's network.
This command center is called the Main Distribution Frame, or MDF for short. You can think of it as the main entryway for all data into the building. Every bit of information, whether it's from your internet service provider or a private phone line, has to pass through this central point first.
So what's actually inside this brain? Well, you've got the heavy hitters, the core switches and routers that act like air traffic control for all the data. You have the main cross-connects, which are basically giant, super-organized patch panels for every cable coming in and out. Of course, you need heavy-duty surge protection. And often, this is also where you'll find the building's main servers or its central phone system.
Now, where they put this MDF is no accident. It's almost always tucked away in the basement or on the ground floor. And why is that? Well, it's all about creating the shortest, most direct path for those big, beefy service cables to come in from the street and plug right into the building's network.
Okay, so the data has successfully entered the brain. But how does it get from the basement all the way up to, say, a computer on the 10th floor? Well, that's where the spine and the nerve clusters come into play.
And this is our nerve cluster. It's called the Intermediate Distribution Frame, or IDF. These are basically smaller satellite hubs. You'll usually find at least one on every floor, sometimes even more if it's a really big floor. The main signal comes up that spine from the MDF, and the IDF taps into it and distributes it locally to all the nearby users.
And inside one of these IDF closets, you'll find edge switches, which are what your computer actually plugs into. You have patch panels to keep all the local cables organized and manageable. And, super important, you have a UPS, an uninterruptible power supply. It's a battery backup that keeps that floor's network online even if the building's power flickers for a moment.
Okay, I want you to remember this number, 90 meters. That's about 295 feet. This is a huge deal. It's the maximum distance a standard network cable can run before the signal gets weak and your connection gets slow and unreliable. And that one number, 90 meters, is the entire reason IDFs exist. They make sure every single user is inside that 90-meter sweet spot for a fast, stable connection.
All right, so now that we've met our two main players, the MDF and the IDF, let's put them head-to-head. It'll make the differences totally clear.
This pretty much sums it up. First, quantity. It's simple. You get one MDF for the whole building or campus, but you're going to have lots of IDFs. Their jobs are totally different too. The MDF connects the building to the outside world, while the IDFs connect users inside the building. For cabling, the MDF handles the big vertical backbone cables that run between floors, while IDFs manage all the horizontal cables that go out to the desks. And finally, in the hierarchy, the MDF is at the very top, and all the IDFs are secondary to it.
Okay, so we've been talking about brains and nerve clusters, but what does this stuff actually look like? Let's take a look at the real-world hardware that houses this entire system. So the MDF, being the big central hub, is almost always going to be in one of these large floor-standing server racks, the kind you see in a data center. But the IDFs on each floor, space is usually tight, so they're often tucked away in these smaller wall-mounted cabinets that are much more compact and out of the way.
And what's really cool is how modular it all is. You can get specialized racks for different situations, like open frames for easy access or sealed enclosures for a dusty factory floor.
But no matter the type, they all share the same essential building blocks. Any professional setup is going to have cable managers to keep things from becoming a mess, power distribution units, and proper grounding for safety.
So, let's trace that data journey one last time. A signal comes in from the internet and hits the MDF. From there, it travels up the building's backbone to an IDF on your floor. That IDF then sends it through a local cable right to your device. It's a clear path, from the brain, up the spine, through the nerve cluster, and right to your fingertips. This brings us to a really interesting question. With Wi-Fi getting faster and more powerful all the time, are all these cables and closets just going to disappear? The answer is a hard no. And here's why. Every single one of those wireless access points still needs a physical cable to connect it to the network. As our hunger for data continues to explode, these hidden hubs aren't just going to stick around. They're going to become even more vital. It really makes you wonder, what will the nervous system of the smart buildings of tomorrow look like?